Dear NEET aspirant, see this subtopic of the some basic concept of chemistry unit. Actually, we know that, or we most familiar the substances weight or the amount of substances. Okay, the amount of substances that is classified as a macroscopic level, macroscopic, and there is a microscopic level. Okay, microscopic level. So this macroscopic level, we go to that milligram unit and gram unit and the kilogram unit even at all. Okay, okay. So this is a mostly the macroscopic level we can using this unit. But in the case of microscopic level, we can go to that mole. Okay, okay. So this is a mole. That's simply in the unit for counting the entities at the microscopic level. Okay, okay. So the fundamental system of there is a the amount of substances, actual the SI unit, amount of the substances, there is SI unit as a mole. Okay, okay. So this mole is nothing but the amount of substances that containing as many particles or entities as there are atoms exactly. That's a 12 gram of carbon, 12. Okay, 12 gram of the carbon 12 isotope. Actually this mole, there's 12 gram of carbon 12. Okay, so divided by, there's 1.992 into 10 to the power of minus 23 gram of carbon 12. Okay, so this 10 to the power of minus 23 is inverted. We can get that is a 12 divided by this 1.99 is approximately taken as 2 into 10 to the power of 23. So we can go to cancel out, there is a 6. So there is mean is equal to, there is a 6 into 10 to the power of 23. So this is for that Avogadro number. Okay, so we can most accurately finding this Avogadro number, that is equal to 6.0221 into 10 to the power of 23 atoms per mole. Okay, atoms per mole. This is for that Avogadro number. So it's based on that we go to the calculation. For example, now see the mole formula. Actually, the mole it has used for the many formula. There's let's see that one by one. Actually, the mole as representing small n. Here, the mole n, small n is equal to for given weight divided by for atomic weight. Okay, given weight divided by atomic weight, as well as there's a given weight divided by for molecular weight. Okay, so this is the mole. And also suppose if the substances are the liquid or gases, we can go to that volume relation. So that's why the mole n is equal to for given volume, given divided by given volume, suppose here as a liter as a unit, divided by 22.4 liter. Okay, so it's especially for that the standard temperature and pressure condition. And suppose this given volume in ml unit, we can divide it by, there is a 22,400. There is a STP condition also. We can simply changing this liter into that milliliter. That's why we can converting the 22.4 into 22,400. Okay, okay. So next, there is a divided by Avogadro number like that. The mole n is equal to, there is a given number of atoms. There is a given number of atoms or molecules, molecules. Okay, or molecules whole divided by, that's for Avogadro number. This also there is a mole. Okay, so this one formula is used for finding the mole. The next we can go to that the mole at STP and NTP condition. Okay, for example, there is at NTP condition, there is a NTP condition, there is a mole is equal to, mole n is equal to for given volume in the liter divided by 22.7. Okay, so this is one of the formula. Suppose if they have given the ideal gas formula related, we know that the ideal gas formula, what ideal gas formula? Yes, that is equal to PV is equal to nRT. Here P is for that pressure, V is for the volume, N is for number of moles, R is the gas constant, T is the temperature. From this formula, we can converting that number of moles is equal to PV divided by RT. Okay, so this is one of the formula. Okay, actually 1 mole is equal to, there is a Avogadro number. Avogadro number what? There is nothing but 6.022 into 10 to the power of 23 particles. Okay, so that is for 1 mole. For example, 1 mole of oxygen, is what? 1 mole of oxygen is equal to Avogadro number into, that is oxygen atoms. Okay, okay. Then suppose the nitrogen molecule, what? Actually, there is a 1 mole of, there is a nitrogen molecules nitrogen molecules that is equal to, actually there is a previous case also, it's a nitrogen atom, oxygen atoms, 1 mole of oxygen atoms equal to Avogadro number into oxygen atoms. Then similarly 1 mole of nitrogen molecule, that is Avogadro number into, there is a nitrogen molecules, okay, nitrogen molecules, okay. So whatever that we need to finding that 1 mole, we can multiply the Avogadro number with regarding that molecules or atoms, okay. Okay, so suppose the 1 mole of the potassium ions, 1 mole of the potassium ions, K plus, that is equal to Avogadro number into, there is a number of potassium ions, okay. So that is a simple concept. Whatever that we can finding that 1 mole regarding the multiply by Avogadro number into that whatever that asking the question, okay. Then the another one important, actually 1 gram atom, 1 gram atom, that is equal to 1 mole of atoms, 1 mole of atoms, okay. So then also that 1 gram atomic mass. So this relation is also is a most familiarly must be everyone is understood, okay. And there is a number of atoms, the formula finding the number of atoms, number of atoms, that is equal to the n into Na into atomicity, okay, n into Na into atomicity. And similarly number of molecules, that is equal to n into Na, okay. So this is the number of atoms equal to n into Na into atomicity, and similarly number of molecules is equal to n into Na. Suppose they have asking the number of electrons, okay. So number of electrons, that is equal to n into Na into number of electrons in 1 mole, okay. So number of electrons in 1 mole or 1 mole of the compounds, okay. So these all are, there is a very important formula, there is a mostly asking that question, okay. So here the gas constant value, R as a gas constant is R value, there is a dependence on that unit, we can change it, or the change in value, there is 8.314, here there is a joule Kelvin inversion and mole inversion, and also there is a 0.0821 in liter per atmospheric or liter atmospheric per mole Kelvin inversion, okay. And the similarly caloric unit, this 2 calorie Kelvin inversion per mole or mole inversion, okay. Okay, so whatever that this R values also must be needed to understood to every student, for that reason we can find choosing that every question in the easily for the fourth option or the among the 4 option, okay. Suppose here one question, actually the weight of that carbon dioxide, actually the given weight as a 2 gram molecules of carbon dioxide, 2 gram molecules of carbon dioxide, how much of weight is there? Actually we know that 1 gram, that is equal to for 1 mole, okay. 1 gram is equal to for 1 mole, okay. The 1 mole of carbon dioxide, the carbon dioxide of weight, actually that is a 44 gram. So 1 gram is equal to 44, so that's 2 gram means what? That is a 44 into 2, that is a 88 gram, okay. So that is a 88 gram, okay. So similarly another one question, there is a the 0.1 gram of molecules of sucrose, the 0.1 gram of sucrose, we know that molecular formula C12H22O11. So this the 0.1 gram, how much gram of the sucrose, it's a weight. So like that they have asking the question. Actual the C12H22O11, this for that 1 mole, okay. So this 1 mole of the sucrose, that is equal to 342 gram. So there is a 0.1 mole or 0.1 gram, that is equal to 34.2 gram, okay. So that is answer. Number of atoms for that formula, number of atoms, okay. Number of atoms, what's the formula? N into Na into atomicity, okay. This is the formula. For example, the 36 gram of H2O, now how much atoms are presented? So we know that N as a given weight divided by molecular weight into Avogadro number into atomicity, okay. Atomicity. So this is the formula. Here the given weight as a 36 and water of its a molecular weight as a 18 into, there is a Avogadro number, there is a 6.02 into 10 to the power of 23 into atomicity as here as a hydrogen 2 and 1 oxygen, there is a 3 atom, okay. Okay, so we can go to that simplify this. So this and this, there is a the 6 times 6 3 or 18, Okay, so there's 6 times. This is cancel out. We can go to the 36 into 10 to the power of 23. This approximately this 36 into 10 to the power of 23. Okay, okay. And similarly, there is a the 46 gram of ethanol. What is the atomicity? There is 46 gram of C2H5OH. Okay, so here similarly there is a number of number of atoms that is equal to n as a given weight as a 46 gram, and molecular weight also here the 2 carbon means 2 into 12 that is a 24, and 6 hydrogen 6 into 1 as a 6, and oxygen as a 1 into 16, or 16 is into 1 that is a 16. So here there is a 10 plus 6 there is 16, 6 remainder 1, and 3 3 1 4, there is a 46. Okay, so there is a 46 into Na into here atomicity as a 2 plus 5 7, 7 plus 1 8, 8 plus 1 9. Okay, okay, this is 46 is cancelled out, so there's a 9 Na, 9 into 9 into Na. Okay, so this is the answer. Actually 9 into 6 into 10 to the power of 23. So that is value is equal to 9 into 6 as a what? Yes, there is a 54 into 10 to the power of 23. So this is the answer. Okay, actually this see this one problem. The number of molecules present in 1 ml of water vapor at STP condition. So these 4 option is given. It's a very simple easiest question in the mole concept. Okay, so here that volume as a given in the unit as a ml. Okay, so we know that there is a 1 mole. Okay, 1 mole that is equal to 22.4 liter. Okay, so volume is occupied. So suppose there is a liter, but in the question is given in the ml unit. That's why we can converting the liter into ml. So 1 mole of gas that is equal to 22,400 milliliter. Okay, okay. So actually there is 1 mole of gas occupied as a 22,400 milliliter of volume, and so 1 ml volume, how much mole is occupied? So we can go to that interchanged cross multiplication. So we can get in that x into 22,400 into 1 into, or is equal to 1 into 1. Okay, so here that is x is equal to, that is a x is equal to there is a actually there is 1 mole is equal to what? There is a Avogadro number. Okay, so we know that x is equal to 1 into 1 into Avogadro number 6.02 into 10 to the power of 23. So there is a x is equal to divided by x is equal to 1 into 1 into Avogadro number. Actually there is a 6.02 into 10 to the power of 23 divided by this 22,400. Okay, okay. So now we can go to this solve in this value. This is a actually x is equal to we can go to this solve this value 0 0, this cancel out. There is 10 to the power of 21 is like that. Okay, so 6 divided by 224 into 10 to the power of 21. Okay, okay. So this we can go to this solve in the answer almost getting the 2.69 into 10 to the power of 19. Okay, okay. This is the answer. It's where it's present in that option in this question. Yes, where this C is the correct answer. Okay, okay. Actually, the mole concept is a very easiest topic in the some basic. If you like in this video, you can subscribe and share your friends. Thank you to all. That is for upcoming videos. The empirical formula and molecular formula, stoichiometry and elliptic reagent. We will see very soon. Okay, thank you.